Okay, we're on number 7 from the notes, and we're talking about a cylinder. And it gives you, it says the volume of a cylinder equals V cubic inches, and V is a constant. Minimize the surface area. So what they mean by V is a constant is they want to keep the volume of this whole cylinder the same. So they want to know the minimal surface area that'll give you the same volume. And think, if you were trying to make a product and you wanted to use the least amount of surface area material, right? To give you the same amount of volume. What would the shape of the can be? And they mean like if you make the radius smaller, then to have the same volume, it would have to get taller, right? If you make the radius shorter, it would have to get wider. And so where would be the best place to minimize that surface area? So to me, this makes sense. So let's talk about what we know. We know the volume of a cylinder is pi r squared times h, the volume of the base, this times the height. And we also know that the surface area, and if you don't, you need to know this, is the area would be the area of the two bases, so the top and the bottom, that's 2 pi r squared. And then the part around the center would be the circumference times the height. If you flatten that out, it becomes the circumference times the height. So there's our surface area formula. Now, we need to use volume because that's going to stay a constant. So we would solve either for R or for H. But I'm going to solve for H because it's only used one time in the surface area formula. So we'll say H is V over pi r squared. Okay? So we come back over here to the surface area equation and we substitute in for H, V over pi r squared, and we simplify that, crossing out the pi's and one of the r's, and we get the surface area as 2 pi r squared plus 2v over r. So now we want to minimize this function, so we are going to take the derivative of the surface area and we get 4 pi r plus negative 2v r to the negative 2, or rewrite it, 4 pi r minus 2v over r squared. And we set that equal to 0 to minimize it. Now, the thing about it is we don't want a v, now that we've taken the derivative, we don't want a v because we need to know the dimensions. So we need r and h. So you've got to go back and put that v is pi r squared in this v. So I get 4 pi r minus 2 times pi r squared h over r squared. So I just replaced v with pi r squared h. And set that equal to 0. So I have 4 pi r equals, and the r squares would cross out, 2 pi h. So r is equal, you could have solved for h either way. Just when you talk about the answer, you would be talking in terms of height instead of radius. R equals 2 pi h over 4 pi, cross the pi's out. That becomes a 2 and a 1, so we get r is 1/2 h. So it minimizes when the surface area minimizes when r, the radius is half the height. So that's what they wanted to know. So that was number 7.